Okay, so let's scoot on to this new topic called partial fractions. And you're like, well, what does that mean? Here's the deal. You guys know how to add fractions together, right? What do you do to add fractions? Yeah, you get a common denominator. Agreed? So for instance, if you were adding 1/4 plus 1/3, you would change them both to denominators of 12, which means this would become 3/12, this would become 4/12, and you'd finally be able to add them together and get the answer of 7/12. Agreed? So we're used to getting the two fractions to add or subtract together, finding a common denominator if necessary, and then getting the answer, the result. Well, this section throws it in reverse. They're going to give you the answer of 7/12, so to speak, and you got to go backwards to find what two or maybe even three fractions you added together to get that 7/12. Now, 7/12 is just an example, but you know what I mean, right? Okay, and clearly I have some steps for you. So at this point of the video, I would suggest that you pause and write down these steps, and I'll be right back with a problem that we're going to work on. So let's take a look at this first problem. The directions say decompose. Decompose means break down, doesn't it? So here's the deal. This is the answer. And they want us to come up with the fractions that we added or subtracted together to get this answer. Are you with me? This is what decompose means. So, let's go with our steps. What's step one say? Yeah, if the numerator, the degree of the numerator is greater than or equal to the degree of the denominator, then we're going to have to divide. Okay, so let's take a look at the degree of the numerator. Remember, degree of the numerator means the highest power. So what's the highest power in the numerator? Yeah, it's a 1. What about in the denominator? It's a 2. So is the degree of the numerator greater than or equal to the degree of the denominator? No. Good, so I don't have to divide. And by the way, when they say divide, they mean long division. Yeah, stay tuned for that. You know I'm going to give you a problem. Okay. What's the second step say to do? Yeah, if possible, factor the denominator. So you look at that denominator and you try to factor it. Pause the video, go try to factor it. Okay, you're back. You factored it, right? I know I did. I got it factored to 4x plus 3 times 3x minus 5. That's what mine factored to. Okay? All right. The next step says these factors you just found are the denominators of the fractions you're looking for. So how many factors do I have here? Yeah, I have 2 of them, which means I'm looking for 2 fractions. One of the fractions has a denominator of 4x plus 3. The other fraction has a denominator of 3x minus 5. By the way, it doesn't matter the order in which you write these. You're going to get the same answers, so don't worry about that. And when you write them, always attach them with an addition sign. If it's supposed to be subtraction, it'll work itself out, so don't worry about that. Okay, now that we know these factors are our denominators we're looking for, what's next? Yeah, the numerators. So they told us that the degree of the numerator is always 1 less than the degree of the denominator. So let's look at this denominator. What's its degree? Correct, a 1. So the degree of the numerator would be a what? Yeah, 0? You're like, really? We have 0 degrees? Yeah, we have a degrees of 0. They're known as constants. They're just numbers. There's no x's with them in this case, because x is my variable. There's no x's with them. It's just a number. Do you know what the number is? Yeah, neither do I. So you know what? I am going to call it a. It's a variable, right? How about denominator number 2? What's its degree? Yeah, that's a degree of 1, which means the numerator has a degree of 0, which means this. Yep, you're like, well, if the first one's A, call the second one B. There you go. Okay, y'all with me on this? Now, what's the next step say to do after we get our numerators down? It said to add the fractions. And when you add fractions, what do you get? Good, you get a common denominator, don't you? So this means that my common denominator would be 4x plus 3, the quantity of it, times the quantity of 3x minus 5, right? And to that a, you're going to have to multiply it by 3x minus 5, aren't you? And because that's what you multiplied that denominator by. And to the b, you're going to have to multiply it by, good, the 4x plus 3, because that's what you multiplied that denominator by. With me? Okay. And now when we add when we're adding these fractions, now that I've made the common denominators, right? And I multiplied the numerator by what was needed, I'm supposed to add them. Well, what comes first, addition or multiplication? Yeah, multiplication, which means I literally need to multiply the numerator out first. So it looks like I get 3ax minus 5a plus 4bx plus 3b all over this common denominator. Good? So now you're like, well, what am I supposed to add together? Because nothing is exactly the same. How do I add anything here? Okay, so remember what the next step says? It says to set the numerators equal to each other, right? The original numerator and the new numerator. Agreed? Okay. Do you notice, and I'm going to erase this factor, do you notice the original numerator has x and a constant? And technically speaking, that fraction, even though we don't write it, we should be writing this fraction on every single line to keep us on track. And these guys are supposed to be equal. Do you notice the original fraction, its numerator, is set up with x's and constants? Well, then this is how I have to group these guys. I have to group this numerator in terms of x's and constants, which means I see some x's. I see a 3ax and a positive 4bx, and I see a negative 5a and a positive 3b. Are you with me? And I'm not going to write the denominator for a moment. And here, since the x is in common, I'm just going to factor it out so I can see technically the coefficient of x. Okay. Now, I've added my like terms. I've added the x's together and I've added the constants together. Why? Because my original fraction, numerator, is made up of an x and a constant. So, I've added the fractions together technically. Are you with me? Good. And now the next step says to set the numerators equal to each other, don't they? Okay, so if I'm supposed to set the numerators together, they literally mean the original numerator with the one that you're really looking for, which is this one. Do you notice this says 13x plus 46? On the other side of the equal to sign, do you notice this is a number in front of x plus just a number? Because there's no x with that last parenthesis, it's a constant, isn't it? So check it out. 13 is the coefficient of x, isn't it? Well, isn't the 3a plus 4b also a coefficient of x? Aha! So, you have 13 equal to 3a plus 4b. Yay! And the 46 is a constant, isn't it? And isn't this second parenthesis also a constant because I don't see any x's with it? Aha! So that means 46 equals negative 5a plus 3b. With me? Okay. Now you've got a system of two equations and two unknowns. Your choice how you want to solve it. You want to use substitution, you want to use elimination, you guys go solve it. When I solved it, I ended up with a equaling negative 5, and I ended up with b equaling 7. which tells me this, that the original fraction decomposed to -5 over 4x plus 3 plus -7 over 3x minus 5. Those were the original two fractions that were added together to make up this one. Do you remember what the last step was? Yeah, check it, which literally means if you added these two fractions together, you better get 13x plus 46 over this polynomial. And by the way, these are the factors of that polynomial, so you would get this denominator also, wouldn't you? Okay, cool. Stay tuned. Got another one for you. Okay, so let's take a look at the second problem. The directions haven't changed. They want us to decompose, which means we're trying to find the fractions that we added or subtracted together to get this fraction. This is the answer. Okay, so what's the first step say to do? Yeah, if the degree of the numerator is larger than or equal to the degree of the denominator. So let's stop there a second. What's the degree of the numerator? It's a 2. What's the degree of the denominator? You'd have to multiply these together, right? Well, if you did that, wouldn't you get an x cubed? Yeah, because x squared times x is x cubed. So here's the deal. The degree of the numerator is a 2. The degree of the denominator is a 3. So I guess the degree of the numerator is not larger. So no division necessary. Woohoo! Okay, what's the next step? If possible, factor the denominator. So, can you factor x squared plus 4? Nope, you can't. That's the sum of squares. That ain't going to factor. Okay, so we've already saved ourselves 2 steps of work here. What's next? Yeah, it says the factors that we got from the denominator are the denominators of the fractions that we're looking for, which means in this particular case, one fraction is going to be x squared plus 4. The other fraction has a denominator of x minus 8. And again, we always attach it with addition. With me? Okay. Now what? Yeah, according to the next step, we've got to set up the numerators. Agreed? Okay, so let's look at this one. This has a degree of what? 2, which means the numerator has a degree of? Good, 1. Because remember, the numerators are always 1 degree less than the denominators, which means up here I should find an x, shouldn't I? But do I know the coefficient of that x? Nope, I don't. So we're going to say ax. But it's a polynomial. And so here's the deal. I don't know if this polynomial is supposed to end in a constant or not. Because remember when you write polynomials, you write them in descending order from the largest degree all the way down to the constant. Well, this one needs to end in that constant also. Second degree, first degree, constant, right? Third, second, first, constant, right? Every time you write a polynomial in descending order, it always ends with a constant. Well, even though this is ax up here and it's 1 degree less, it could end in that constant also, and I don't know if I'm supposed to have it or not. So I need to write it just in case. And if the b is not supposed to be there, it'll zero itself out, so I'm not worried about it. Got it? Okay. The second denominator has a power of 1, which means the numerator is a power of 0, which means we have just a number up there, don't we? Okay. And now we're supposed to add these two fractions together, right? Because that's what the next step says to do. So clearly, the common denominator would be the product of x squared plus 4 times x minus 8, which is what the original denominator was, right? By the way, didn't that happen in the last problem? Even though we factored them, if you multiplied them together, wasn't it the original denominator? Yeah, good. Okay, so now we are going to take the ax plus b and we're going to multiply it by, yeah, the x minus 8. Because x minus 8 had to get multiplied to top and bottom. Well, and that c has to get multiplied by, good, ax plus b, because the second numerator, top and bottom, had to also get multiplied by ax plus b. And now I've got to multiply these things out, don't I? All right, so do this with me. Ax squared minus 8ax plus bx minus 8b plus acx plus bc. Okay. So far, so good? Oh. You know what? You guys didn't catch it. I knew this was looking funny over here. Some of you did, though, didn't you? The second denominator wasn't multiplied by ax plus b. What was it multiplied by? Yeah, x squared plus 4. Silly me. Aha! Gratefully we caught it. Okay, so cx squared plus 4c. Okay, much better. All over this denominator. Now remember, we usually don't write it down, but over here on the left side, we should be writing this original problem down on the left side every step of the way. And we don't do it. Why? Because we get lazy. That's just it. We get lazy. Because we're supposed to be adding the numerator, right? Well, you're like, well, how do I add it? You add it based upon this numerator. This numerator is set up with an x squared, an x to the power of 1, and a constant. So when I add this numerator together, I'm going to add the x squareds together because I have an x squared on this side. So that means I'm going to add ax squared plus cx squared. So took care of these two. And then I'm going to add it based on just x. And that would be negative 8ax plus bx. And then I'm going to add it based on the constant, which is negative 8b plus 4c. All over this denominator. With me? Okay. So, I am going to take out the x squared that's in common, so I can see this numerator in the same light as this numerator. Notice this is 11x squared. So I'm going to factor out that x squared so I see a plus c with the x squared outside of it. And on the second one, I am going to take out that x so I can see what the coefficient of the x is. With me? And this last one, well, there's no x's whatsoever, so it's just going to stay as is. Cool? Okay, so hang in there. I'll be right back with the finale of this problem. Okay, so I'm back to finish this problem. So here's where we left off. So this left side, or this right side, must equal the original fraction, right? Okay, so remember what the next step says after we add these two fractions together? It said to set the numerators equal to each other. Well, notice something. This has an 11x squared, doesn't it? On this side, I have a plus c in front of x squared, don't I? Which means what has to be true? If these guys are supposed to be equal, what must be true? Yeah, the 11 must equal the a plus c in order for these to actually be true. Over here on the left, I have a negative 39x. Well, on this side, I have this parenthesis in front of x. So what has to be true? Yeah, the negative 39 has to be equal to a negative 8a plus b. And last but not least, I have the constant of 16, which must be equal to this constant over here of negative 8b plus 4c. Are y'all with me? Okay, so I have a system of 3 equations and 3 unknowns. So it's your choice how you'd like to solve it. If you want to use substitution, elimination, if you want to use matrices, Your choice. But when I solved this system, I ended up with A equaling 5, B equaling 1, and C equaling 6. That's what I ended up with. Which means this fraction decomposed to 5x plus 1 over x squared plus 4 plus 6 over x minus 8. That's what this fraction, this answer decomposed to. These were the original two fractions that were added together to get this result. Good? Okay, stay tuned. Got another one for us.